everyone, and thank you for listening. Welcome to our show where we're talking with the manufacturing leaders whose courage and grit and visionary strategies are revolutionizing this great industry. Today, I'm very happy to be speaking with Dave Merrill, the CEO and co-founder of Elroy Air. His background is in computer science and human-computer interaction, and he's bringing that expertise to his career as a tech visionary. And he's committed to enhancing our global quality of life through advanced air cargo systems. And Elroy Air is pretty unique, to say the least. It's a forward-thinking technology company that constructs large autonomous aircraft systems. They've gained prestigious recognition in the industry, and this is an exciting story for us to talk about because technology is at the heart of it all. It's the wind beneath the wings, we might say. All right, let's get started. Dave, thank you so much for being here.
Happy to be here. Thanks for having me.
All right. So as we get started, can you tell us a little about your background and your journey to Elroy Air?
So I'm an engineer and a technologist. I grew up building things. I was, as a kid, watching my dad do carpentry and home projects and kind of got fearless about constructing things, physical things. And I kind of found my way to computer science. And that was really fun and interesting because I could build behavior that lived inside the computer. I was at Stanford during the days when the Google founders would bring a stack of pizza boxes to the computer lab, handing out free pizza to undergrads trying to hire new people to join their company. I just realized that I was really interested in hardware, software systems. That's why I didn't join Google. But I really got into the kind of palette of tools that you could build with electronics and sensing and software and computation to build useful tools for people. And I almost became an academic. I went all the way through a PhD. And then I remember I was in an interview at a research lab in the Bay Area here in California. In the last interview, the leader of the lab asked me, "So what are you really all about? Do you love building things or doing research?" And in my heart, I knew that the answer was building things.
That's what got you.
And that's what got me. So I didn't do that. I didn't become a professor, became an entrepreneur instead. So this is my second startup. First one was right out of my PhD from MIT. We were acquired by a drone maker, a company called 3D Robotics, which at the time was building commercial and consumer drone systems. And that got me very interested in the utility of things that fly and what else we could do with them. That company decided that it needed to become a software company and pivot. So that wasn't as interesting to me. So that's when I left, went to a venture firm called Lemnos that invests in early stage hardware startups. I was their entrepreneur in residence. And then after 6 months of coaching the other teams they had invested in and helping kind of develop some internal curriculum with them and vet deals, I started Elroy Air. And I already knew that tech at a reasonable level coming out of the drone industry, and then found this huge demand in logistics. And so our mission at Elroy Air is to extend the reach of express logistics to every person on the planet. People don't think about it very much because if it's working well, it's invisible. You just click a button on Amazon and then something shows up at your house that afternoon or the next day or 2 days later. And there's this huge network of logistics that happens behind the scenes to make that happen. But it improves quality of life. And it's great to be able to get things when you need them. And so we have found that logistics needs better solutions. We work across defense logistics, humanitarian logistics, and commercial logistics. And what we're building is an aircraft that is special purpose. It is a dedicated aircraft for point-to-point aerial cargo. For commercial logistics, it's going to be a warehouse to warehouse, what's called the middle mile route. So it's not all the way to your front porch or your backyard, but rather kind of one step earlier in that flow. So creating new cargo routes between warehouses. For defense, it will be serving a resupply for soldiers that are in hard to reach, dangerous to reach places. And then for humanitarian, it'll be taking food and food supplements, water and other materials out to places that are also hard to reach because the infrastructure is damaged or challenged. It's an autonomous aircraft. It is built to carry 300 pounds over a 300-mile range. And some of the special things about it are that it's vertical takeoff and landing. So like a helicopter, it can go straight up and then, cruise to a new location and go straight down. So it doesn't need to operate from an airport or a runway, which means it has a lot of operational flexibility. And then because we knew that this vehicle needed to be purpose-built for logistics, we made it pretty long range, and we gave it the ability to pick up and drop off cargo containers in an automated way, kind of like drop shipping with trucks, where a truck can finish a route, decouple the container, pick up another container, and then the truck keeps going. You can keep that vehicle at a high level of utilization. We've built that model into this aircraft. So the aircraft itself doesn't have to wait around to be loaded or unloaded. It can just pick up a new cargo pod and go. The value proposition to our customers is that Chaparral, that's the name of our aircraft, it's going to save time. It's going to enable more express by cutting steps out of that middle mile and enable air shipping everywhere without airports. I mentioned kind of the middle mile commercial opportunity, like why that's meaningful is that it's good for people who will get same day shipping and next day shipping. And it's good for the shipper, like a FedEx, because express is a good part of their business. It's a high margin part of their business. So they also want to do more express to serve their customers better. In defense, de-risking resupply missions in contested environments is hugely important, because today in a battlefield, you do resupply missions using trucks on the ground, which can encounter IEDs and dangerous missions, or helicopters in the air, which also can be in the line of fire and can be very dangerous missions. There's really no price you can put on human life. And so being able to send an aircraft that has no person on board to go and deliver goods from one place to another on a battlefield is transformational for defense. So to give you the kind of snapshot of where we are a startup, but we're not an early stage startup. We're about six and a half years in on this journey. We're based in South San Francisco in the California Bay Area. We have raised more than $80 million since we started the company with investors like Lemnos, Catapult Ventures, Lockheed Martin Ventures, other strategics. And today we just crossed 80 people. So 80 something people, mostly here in South San Francisco. But we have, engineering talent from companies like Airbus and Kitty Hawk, Joby, SpaceX, Blue Origin, and also aerospace manufacturing firms like Ascent Aerospace and Toray Advanced Composites. Our customers include FedEx, Bristow, aircraft lessors like LCI that build a fleet and then lease out to operators, Mesa Airlines, the U.S. Air Force, and then other major humanitarian air shippers too. So today we have more than 1,000 systems in our demand backlog for our Chaparral aircraft systems, and some of these with deposit-backed agreement. And so our challenge is, speaking of manufacturing, our challenge is like, how do we get these systems into production and get them out to our customers as rapidly as possible? We've also, so kind of technology trajectory, we have flown multiple generations of prototype aircraft. Starting in 2018, we flew subscale, so smaller versions of the Chaparral vehicle. We flew a full-scale aircraft in 2019, and then we've been building and testing subsystems, during the pandemic and beyond. And then we unveiled the product configuration of the aircraft early last year, and we'll start flying it with the U.S. Air Force this summer. So coming up very soon. One of the exciting recent milestones is that what we're doing now is we have the aircraft out at a test facility out in the California Central Valley. So beautiful wide open space. We have a hangar, and we are tying the aircraft down to these concrete jersey barriers, kind of like the barriers that go along highways, and then powering it up and stepping it up from, just spinning the vertical rotors and forward propulsors all the way up to 100% power level for hover. Hover is that's kind of the maximum power level of a flight. So we recently got it all the way up to 100% and held it sustained at 100%. So that's one of the major boxes that we needed to check before leaning into the flight test campaign was, bringing it all the way to maximum power, making sure that, nothing went up in a puff of smoke. And so far, so good.
That's great.
So our goal is we're going to be in production. We're going to be flight testing with the Air Force, and then goal is to be in production of systems for customers by the end of next year.
That's incredible. So many achievements, so many milestones. Congratulations on so much growth. And you're doing great work, really important, great work. So thank you for sharing that with us. I'm interested in, we're talking autonomous aircraft, right? But your background, almost an academic, turned entrepreneur, business leader, your background in computer science and human-computer interaction. How does that influence the manufacturing process and what you do with this being autonomous? Like you said, the logistics should just work. These things should just work in the background. What is the human component?
Yeah, good question. I've always been fascinated by the way we interact with technology. And that was, as you mentioned, a lot of my research work before I launched out into industry was about kind of building new tools for human-computer interaction, new interfaces. It's something that I find personally really fascinating. I've always been geeky about like game controllers, and when touch screens started to become prevalent, like that was really exciting. And just the kind of the ways that computers and hardware, software, robotic systems become an extension of our intentions, an extension of our capabilities. I think that's kind of the technology as a tool for expanding what we can do. That's really the fundamental and timeless value of tech. And so that interaction of like, well, how do we actually use the tech, to me has always been really fascinating. I guess I would say I have a personal bias toward automating processes that we do repeatedly. A software developer hates to write the same code twice. You don't want to put the same code logic into two different places when it could just be in one place, and make sure it's correct there and then call upon it from everywhere you need that functionality. I think my interest in human machine teaming does play a part in manufacturing. I got to know manufacturing fairly well for consumer devices back earlier in my career, building drones and other consumer electronics. Now, today, I'm learning how this works best for aerospace. And, caveat, I'm not an expert in manufacturing. I've built a team around me at Elroy Air that are far more expert than I am, including our chief operating officer, my co-founder, manufacturing engineers on the team. What I've come to understand is that, digitization, automation, these are things that are super important to get to scale and to do them at scale. But when you're in a research and development phase where you're trying to move really fast and build something quickly, learn from it and iterate from it, you end up leaving a lot of the digitization and automation on the cutting room floor. You don't want to put those processes in place too early because it can slow you down in the development process when you're trying to just iterate and learn and improve the product rapidly. Our current vehicle is called the C1, the Chaparral C1. And this is like building two of them. These are the prototypes that'll demonstrate the complete kind of mission end to end, from takeoff, transition, cruise, come down, land at the other end. For the first C1 vehicle build, we were keeping records in binders on paper as we assembled the aircraft. Like, we didn't even stand up a fully digital system to build the first one. Now we're digitizing those records, and for the second vehicle behind it, we're doing more of that process with digital records. So that's been something that it's been interesting to learn, that we've decided that we don't want to put too much process in place to digitize or automate, because it will slow us down in this research and development phase.
Yeah, that is a balance you have to strike, right? And I can imagine getting to that understanding of the balance could be a challenge. What are some of the challenges that you had to overcome as you're going through this process?
That tension really between moving fast to design and build and fly a prototype, and then building the processes to enable a repeatable aircraft build. Ultimately, our job is to build a business that can knock out repeatable aircraft at a high rate, so that we get these systems out to every customer in the world that needs them. But the first couple steps are prove the technology works and go and demonstrate it with customers. And so in the early days, as a investor-backed, venture-backed company, like our incentives are not to build kind of the perfect automated manufacturing line from the beginning. Our incentives in the early days are just show that it works in the shortest period of time. And so it kind of, there's a tension against the sort of maturation of systems. So for instance, question we asked ourselves was, when do we need an ERP system? When do our assembly technicians need digital work instructions on the shop floor? How do we keep these instructions up to date when our engineers and techs are making decisions on a daily basis where they find out, I don't have enough wrench clearance to get this bolt in, so I need to do something different. Like there's things that we're learning as we go. And then how much of the knowledge is documented? How much is just in the heads of our team? So I think in the summary of how we overcame this or how we addressed these tensions we were very thoughtful, and we kind of learned quickly to right size the amount of process that we put in place and to really be explicit about how much process we're putting in at each step of building these early aircraft so that we wouldn't overdo it. We need enough that we can go back and look, which part went on the vehicle, where did it come from, kind of the basics, but not too much. And then adopting an ERP system that wasn't too kind of heavy for our needs. So started simple as a platform to build on. The important early steps are to tracking of direct materials and budget. Material control is also something that's critical in aerospace. You need to know where every part came from. So putting the first floor in place early kind of gets the whole team calibrated and at least gets the muscle memory going of using that system, even if we're not kind of using every part of it yet.
So within aerospace and defense, I imagine there must be compliance regulations that you have to adhere to as part of that process. I can imagine that would make it extra complex.
Yes. Ultimately, we will need a manufacturing certification in order to produce, type certified aircraft for use here in the national airspace. In the near term, though, like I mentioned, we're in the development phase, in the R&D phase. And so the requirements are different. The bar isn't quite as high for what we need. I'd say one of the interesting constraints that we've navigated is that, because we're building a system that is relevant to the defense community and we have multiple contracts with the U.S. Air Force, we have to make sure that the supply chain that we use to build the aircraft doesn't include parts from China, for instance. And so that's been, since early days as we've developed this aircraft system and figured out which partners we can use for subsystems, that just had to be a rule. There are parts that we've avoided deliberately for that reason, because we just understand that that's a constraint that we need to operate under.
Yeah, I understand that. You need that visibility across the supply chain to comply with the regulations that the government has. But you are in this sort of unique phase where you get to do this development, but building in these processes, as you said, that are right sized to the business. So could you summarize where you are today in terms of what types of technologies that you've embraced to transform the business?
So, fundamentally, our business is about building new technologies. So we're building this autonomous aircraft. Each team that's responsible for a piece of the overall product has their own deep bench of tools that they use. The software team is using GitHub and other software tools and ways to track requirements, documentation. From the manufacturing point of view, we're in an evolution process. So we're ramping, like I said, from kind of paper and pen record keeping to spreadsheets to ERP. Paper and spreadsheets got us through the first iteration, and now we're basically leveling up. The ERP system is going to grow with us and will kind of act as the backbone upon which we integrate more advanced digital factory applications and tools. In aerospace, manufacturing or managing the digital lifestyle from the design, from procurement, manufacturing, integration, flight testing, in the field monitoring, that's all really essential. And so we're consciously planning out how we're going to use these digital tools in their best use over the full life cycle of our Chaparral product. Some of the systems, tools that we use, like for system engineering definitions, We need to make sure that our vehicle meets specifications. We understand failure modes, have a fault tree. So system engineering software tools and requirements management tools. We do a lot of simulation. This isn't specifically related to the manufacturing, but we do, just to make sure we validate the product functionality, we do software validation. So we build like a software flight environment that we can fly a virtual copy of the aircraft. And when we're flying in that virtual environment, we're using the actual flight code and the actual control laws that will run the vehicle itself, but first in simulation. Then what we do as a next step is we couple what's called a hardware in the loop system alongside the software simulation. And hardware in the loop is kind of like the nervous system of the aircraft, but on the benchtop. So it's all the avionics, the ruggedized electrical, computers and electric connections between the computers that are all going to be distributed throughout the aircraft. But we kind of build up a board that holds them all on the benchtop, so we can run that with the software simulation. So, if you think of like the software simulation as kind of like a dream world where we can run like thousands of missions of our aircraft in the cloud, it's kind of like imagining these missions. Putting the hardware in the loop means that we can kind of run that nervous system alongside that simulated flight and find problems that you'd only really find on the hardware. So, bottlenecks of communication, or, what happens if you pull a plug on one of the flight control boxes? Does the rest of the system respond gracefully and compensate the way it's been designed to if something goes down? So that's kind of step one, step two. And then the third simulation that we do is we've built what's called an iron bird, which is common in aerospace. It basically is like the guts of the aircraft, also kind of spread out on the benchtop, or in our case, on the back of a trailer. So we've got this big trailer in our shop that holds the engine, the generator, the battery, the power distribution electronics, and then the rotors. And so it's kind of like a copy of the aircraft, but like installed on a trailer instead of packaged into an aerodynamic shell. And so we can run this thing up, this powertrain, representative powertrain, all the way up to full power levels of what the aircraft needs to do for flight, and hold it up there, make sure that everything's working, cycle it up and down the way that it will during an actual flight mission. And the reason we do all this kind of simulation, whether it's pure software or hardware in the loop or the iron bird with the powertrain, is that it's just so important in aerospace to get it right. Like the vehicle, if something goes wrong in flight, God forbid it's an airplane with people on it, but even an uncrewed system that there's not going to be a human being on, if we crash it, it's a very costly loss of a prototype. And it's costly in money, it's costly in time. And so we really want to make sure that we have kind of ironed out all the problems before we go out and start leaning into our flight tests. And so this is the way that we do that, is trying to simulate and track down and extinguish all the bugs, all the problems before we're out there putting the aircraft at physical risk. Because we'll never have a brilliant test pilot on board this thing who can save the day if something's going sideways. We really have to test in advance.
Yeah, it makes complete sense. I mean, you really wove in technology through everything. And I see how it very closely aligns to the mission of Elroy Air. It seems like all of this has had a massive impact on your business, your operations, the safety, and cost effectiveness. When it comes to new technology, where do you go from here? What are your top priorities as you're looking out into the technology landscape that you might consider including next?
Our job is to move fast and to deliver a game-changing, world-changing product. Our specific job is not to get to a 100% digital process if we can move it faster at 85%. So we're going to tune that knob very carefully of how digitized does the whole thing need to be. We do embrace, and we're going to keep evolving up to the concepts of the digital factory and really carefully best match the tools to the needs of our assembly and integration operations. We're building vehicles that have to obey the laws of physics, and so they do require often a more hands-on kind of build and craftsmanship process, especially in the early days as we're kind of iterating to perfection, so to speak. I guess, rather than being able to cite exactly which tools we're going to use and when, I can say, if you look out ahead of us in time, the early job for us now is prove the technology works. The medium term job is to prove the value prop with customers. That's, coming up soon. And then the long-term job is to scale up the operation and have a very efficient manufacturing and vehicle operation capability. And ultimately, as a startup, have an exit for shareholders, for the team and the investors. So we're gonna pick the right tools at the right time to enable the short, the medium, and the long-term goals.
It's really interesting when you think about Elroy Air and the advancements that you've made in this industry. I was just thinking back to a little bit earlier this summer. My family and I visited the Outer Banks in North Carolina and Kitty Hawk, North Carolina, right, is where they say flight began with the Wright brothers. This industry really has been, traditional for some time, but you've really pushed the boundaries of innovation within flight and autonomous vehicles. I know that there are other manufacturing leaders who are probably listening in, others in manufacturing, maybe others not yet in manufacturing, and they want to do something innovative in their space. How did you get to the point where you were comfortable pushing the bounds? Do you have any advice for other leaders who are thinking about a very traditional industry and then taking it into a totally different, or, maybe it's not even that different. Maybe it's just an adjacent industry where they have to really innovate and do something different. What would you say to others as advice?
Well, first, that's very cool that you got to visit Kitty Hawk. I need to go visit Kitty Hawk someday.
Would love it.
So you read the biography of the Wright brothers. It was a real kind of austere situation that they were in out there, that they were basically camping when they went out multiple times to go and test fly their aircraft. And I think that there's something about that. And, the reason why the Wright brothers were successful in my mind was that they just got obsessed with flight. And it's like all they thought about and talked about and argued about. And the fact that there were two brothers and they could just talk about it all day long and debate and figure things out, I think helped. That's actually one lesson that I would say for leaders that are trying to do something challenging is it really helps if you can just get comfortable being uncomfortable, because there's a lot of discomfort in building something new that hasn't been built before. It takes sheer persistence at times, keeping a team motivated through a long process that sometimes the rewards come kind of intermittently, the milestones, raising money, convincing customers to believe in the product. So I think that's probably the number one piece of advice, is that building something new is going to take way more effort than you think. And it's kind of a lifestyle choice where, many people who are fortunate enough to think about starting a company to manufacture something new probably also have other options for what they can do in their life, which would be a lot easier and cushier and create less discomfort. And so that's a deliberate choice. You'll make more money probably in the near term, not starting a company, but if it all works out, then it can be amazing. I'd say some more specific advice about kind of manufacturing leadership and how to do it. If you're like me, where I didn't start out as a manufacturing engineer, I don't have a formal background in manufacturing, hire someone who is action oriented, comfortable with ambiguity and comfortable with discomfort, and who understands manufacturing. And then work with that person to make sure you're using the right tools and systems at the right times. Manufacturing at the level of complexity that we're doing is this medium to long game to scale, and expertise is built carefully. So you got to be efficient with capital, yet produce high quality, cost effective products, along the way. I'd also recommend hiring somebody like a CFO as early as possible when there's a capital intensity to the enterprise. I think that really helps. We did that almost 2 years ago now, and it's been great, super helpful. Make sure the lines of communication to the team doing the actual assembly and the manufacturing work are really healthy and productive, and there's a lot of trust and transparent communication. Digitize what makes sense, the parts that enable iteration, what enables kind of optionality for the future. Don't digitize something too early if you don't need to do it at that point. And then, I'd say advice from our COO, who's the manufacturing expert, is embrace the first principles of lean manufacturing at an early stage. And he would agree with me on this. Don't over digitize too early. You might add processes or controls too early. And then when you need flexibility and rapid iteration, really that's the name of the game in the early days, is prove the technology works. And so you could end up slowing yourself down if you try to introduce too much process too early.
Great advice. I really enjoyed talking with you. As we wrap up, for anyone who wants to learn more about Elroy Air or learn more about you or connect with you, where can they find more information?
Our website is a great place to get the overview of what we're doing. It's elroyair.com. You can find me on LinkedIn, David Merrill, even though I go by Dave. Yeah, if anyone has specific questions, that's probably a great way to reach me. Is just send me a note on LinkedIn.
Well, this is wonderful. Thank you so much, Dave. I really appreciate it.
My pleasure. Happy to join you today. Thanks for having me on.
All right. Thank you so much to my guest, Dave Merrill, the CEO and co-founder of Elroy Air. And thanks everyone to listening. Thank you for being a part of the future of manufacturing.